Hi everyone. Karen Yoshida Weldon is a Great Lakes Summer Fellow at the Cooperative Institute for Great Lakes Research. Karen graduated from the University of Michigan in April with an MS in Environment and Sustainability and an MA in Japanese Studies. Before coming to Michigan, Karen worked at a watershed conservation organization in Japan, supporting research, education, and farming around the Kahukugata Lake and its neighboring rice paddies. At the University of Michigan, her capstone project focused on estimating the value of carbon in agricultural land and forests in Michigan. As you'll soon see, her project on blue carbon in Great Lakes coastal wetlands brings together her interests in watershed restoration and conservation and skills in ecosystem service valuation. With that, I'll hand it over to you, Karen.
Thanks so much, Kate, for that introduction. I'm really excited to be here today with everyone and share some of my research in my presentation entitled Exploring the Value of Great Lakes Blue Carbon. So first, before I get started, I wanted to share a thank you to everyone who's made this research and work possible. So first of all, to the National Ocean Service and NOAA Central Library, and particularly Lisa Clark here, who is hosting me on this webinar series today. Secondly, I'd like to shout out to my project mentors. I've had an amazing team this summer: Kate Quigley, Chiara Zuccarino-Crow, Laura O'Brien, and Jennifer Day, who've been really supportive of me this so far. In addition, I'd like to thank the CIGLR fellowship staff for their support and putting this fellowship together. And then finally, NOAA staff and partners who've shared their resources and information and had conversations with me about Great Lakes coastal wetlands and blue carbon storage. So I'll begin my presentation today with a background on blue carbon valuation and the motivations for my project. Then I'll dig into my research questions, which explore existing data and the value of blue carbon. Afterwards, I'll take a look at my initial results, an assessment of existing data on blue carbon, and then preliminary estimates of blue carbon. And I'll end with some applications and recommendations for further research. So first of all, some basics about blue carbon valuation. So ecosystem service valuation is increasingly used to capture non-market value of natural resources. These can be cultural resources like the wild rice pictured here, as well as things like carbon storage and carbon sequestration of different ecosystems. Today, this process is particularly important, or today, and is sort of important for this talk, is that ecosystem service valuations are really critical to developing carbon neutrality goals and greenhouse gas reduction goals. I'll be focusing particularly on blue carbon, which is carbon stored and sequestered in coastal habitats. So far, there's been a lot of interest and focus on saltwater marine ecosystems. So these involve salt marshes, mangroves, and seagrasses. So of course, coming from the Cooperative Institute for Great Lakes Research, I want to talk about Great Lakes and their wetlands, but also this has a really important in general to global water systems. The Great Lakes contain 1/5 of the global freshwater, and the lakes and their watershed provide numerous ecosystem services. However, this is facing some challenges right now. Currently 50 to 65% of coastal wetlands have already been lost. And this has been leading to numerous challenges, ecological challenges with things like invasive species and loss of habitat, economic challenges, flood protection is lost, and then again, those cultural traditions I was sort of alluding to earlier today. So given the importance of wetlands in the Great Lakes region, there's been significant resources invested into measurement, conservation, and restoration of these spaces. And so as NOAA has increasingly been interested in looking at adding ecosystem service valuation to their work around the Great Lakes, looking into blue carbon, an area that a lot of interest is had nationally, seemed like a good place to start. So that leads me to my research questions. So my research this summer examines the ecological and land cover data around the Great Lakes and blue carbon storage. So I ask, does the ecological and land cover data exist to make estimates of the value of blue carbon in the Great Lakes Basin that are considered reliable and comprehensive? And secondly, what is the value of blue carbon stored in wetlands in the Great Lakes? So before answering these questions, I want to introduce a few key components of the valuation process. So first, how is blue carbon measured? There are two primary ways to measure blue carbon. The first is the amount of carbon that's sequestered through wetlands. This is the value that carbon has as the wetlands have through mitigation and through their ability to remove carbon from the atmosphere. The second way of measuring blue carbon is through examining the carbon that is stored in the wetlands. And so thinking about this is the value of conserving those wetlands opposed to draining them or flooding them. Another way to talk about this, particularly if you're thinking about carbon offsets, an area where carbon is often valued is avoided carbon emissions. So once a measurement of carbon is made, that amount is translated into dollar values, typically for a blue carbon valuation. And there are two ways to do this as well. The first is through market price, so the value that in carbon markets, blue carbon is getting on the marketplace. And these can be marketplaces like the California system or RGGI on the East Coast or the voluntary carbon market that companies are buying into these days. The other approach is using the social cost of carbon, and this is the cost of damages caused by each additional ton of CO2e that is emitted into the atmosphere. And this is a number that is created through lots of modeling about the impacts of climate change globally. And it's used particularly by policymakers and decision makers around different projects and monitoring the climate change. So I'm going to dive now into my research question and begin by tackling my first question around existing data. So first, does the ecological data exist to make reliable estimates of carbon sequestration? My answer to this is no, and there's a number of reasons for that. And first of all is that the water levels in the Great Lakes can change very drastically. You can sort of see this here. This is a graph of Great Lakes water levels developed by the Army Corps of Engineers. On the left-hand axis, you can see the meter measurements, and on the right, it's in feet. But on the sort of the left-hand side, I want to draw your attention to again. It shows like a difference in 1 to 2 meters, and that blue line is the monthly mean. So you can see a lot of fluctuation in water levels in these different lakes. So, these changing water levels can lead to significant carbon stock losses. So even, though there's lots of carbon being sequestered, a lot is being lost at the same time. In addition, anaerobic conditions can lead to methane emissions. And this is particularly a challenge in freshwater coastal wetlands, where there's sort of a lot of methane being emitted, and that can cancel out the sequestration benefits. So my answer to this question, is no. Well, we have these two processes that sort of can cancel out sequestration, which is suggesting that carbon sequestration might not be a value that we can add. And additionally, not that many models incorporate both aspects of this, sort of the water level changes, as well as sort of the processes within the wetlands themselves. So wondering how these two processes interact to sort of understand the overall carbon budget of wetlands. So I want to turn to my second way of valuing carbon, and that is through carbon stocks. So here I ask, does the ecological data exist to make reliable estimates of carbon stocks? So my answer here is yes, but it could be better. So research suggests that regional soils have high carbon stocks, particularly high in the nation. However, there's a number of disagreements about how to measure carbon stocks, and this can involve how long those soil cars that are taken are. Is it 30 centimeters enough? Do we need to go all the way down to 120 centimeters? And then a lot of estimates are made with really a limited number of measurements. So trying to understand the carbon storage of a very large area of land with just a few measurements. Next, I'll turn into another component that's really important to understanding and developing reliable estimates of blue carbon, and that's around land cover. So does the land cover data exist to make reliable estimates of blue carbon? So I have another similar answer here. Yes, but it could be better. So there's a number of different organizations that are collecting data and making databases on wetlands in the Great Lakes. So you can sort of see some of the organizations here. But as I was exploring these different databases, I came to realize there's a number of trade-offs that are being made. So some databases have a really high spatial resolution, others show change over time, Others show wetland extent very precisely. Others are really good at incorporating land use or wetlands condition, but there's no really encompassing database that really takes into account all these different factors that would be really helpful in understanding and estimating blue carbon. I want to go now to my next research question. What is the value of blue carbon stored in Great Lakes wetlands? So to answer this question, I began by combining data from a number of different sources to understand that wetlands extent. So I used the USGS's wetland basin to sort of understand the area that I would be looking at, and then laid on different data from the National Wetlands Inventory, which is developed by the US Fish and Wildlife Service, that really measures wetlands very precisely, as well as information developed by NOAA around the coastline. I used some information on the ordinary high water mark. You can sort of see in this map here, that dark line on the US side of the Great Lakes are the wetlands in the US that I was trying to measure. It becomes a little bit more clear if we take a look at it, take a look at that information right here. So I've zoomed in here on one area of the coast, and you can see the wetlands in that pink and green area. There's two wetlands being measured here, freshwater emergent wetlands and freshwater forested and shrub wetlands. And so first, after a number of conversations with experts on carbon accounting and sequestration in wetlands, I decided to focus in on emergent wetlands. And so sort of isolated for that green layer, I guess it is, there. And then calculated the extent or sort of the area of those wetlands within 300 meters of the high water mark. And I made this decision again by looking at different research on sort of estimates of how to measure coastal wetlands, which turned out to be a lot more challenging, as I'll get into later, but decided on this initial extent for coastal wetlands. So then I took that number of emergent wetlands, and as you can see on the left-hand column here, we have 55,460 hectares of wetlands. And then I took a carbon storage rate from a study I mentioned earlier that looks at carbon sequestration across the entire United States, and got a range of values from 23.3 million to 29.7 million tons of carbon stored in those wetlands. Then I applied the social cost of carbon to understand the value of the wetlands here. So actually the social cost of carbon is sort of an interesting moment. It's being estimated in very different ways by different groups. The Biden administration values the social cost of carbon at $51 per ton of CO2e, while the Environmental Protection Agency has recently released a much higher value of $190 per ton of CO2e. So given the sort of broad range in the value of the social cost of carbon, I decided to estimate this value both for the Biden administration's rate as well as the Environmental Protection Agency rate. But as a result, we have a very wide range of this value, right? It ranges from $4.4 billion to $20.9 billion at the far right end and bottom number there. Okay, so I want to put these numbers in context. I guess I'll jump back here, sort of this lowest number of carbon storage and then this lowest value of what it's worth. And to sort of put these numbers into context. 23 million tons of carbon is the same as the CO2 emissions from driving 19 million gasoline-powered passenger vehicles for a year. Or if you want to put it another way, it's the CO2 emissions from 215 natural gas-fired power plants over a year. So this is a significant amount of carbon, right? It's a really sizable amount of carbon that's being stored in these wetlands. And so unsurprisingly, that number of 4.4 billion is also a pretty sizable number. NOAA's Office of Coastal Management has been collecting data on the Great Lakes regional marine economy and has estimated that the GDP as of 2019 is approximately $21.5 billion. So that $4.4 billion is approximately a fifth of the GDP. Again, not numbers to sneeze at. So I think there's a lot of opportunity to share this kind of work, and that can really be helpful in decision making moving forward. So currently, actually, the Office of Coastal Management is in the process of updating their coastal county snapshots. You can see here, this is their tool that sort of provides information on these top indicators for assessing the economy in different ways, but they're hoping to make an addition to this process on coastal wetland snapshots. And this will take into account things like the value that these coastal wetlands provide for flood protection, as well as blue carbon. Currently, these measures are focused on the salty coasts, not the Great Lakes, but there is hope in the future that this might be expanded to focus on the Great Lakes as well. So maybe this kind of this research that I'm sharing today can contribute to that work. In addition, there's a lot of applications more locally. There's a number of organizations that have gathered together as the Great Lakes Coastal Assembly. Over 20 different organizations, from federal groups to tribal groups to other conservation groups, have come together to conserve coastal zones in the Great Lakes region. They're currently in the process of developing an assessment of coastal health and conservation priorities. And understanding the value of blue carbon can help with that process. Healthy communities, right, need to have a livable climate, and so these numbers can really be helpful in providing targets and estimates for areas where wetlands should be restored and that value of restoration. However, before we go and sort of share these numbers that I've shared with you, there's a number of ways that we could improve the accuracy of valuing blue carbon in Great Lakes coastal wetlands. First is a standardization of some of the geospatial data. I've already alluded to a little bit of this earlier with those different databases that are measuring wetlands, right? Each one had different pros and cons, and so being able to synthesize that information would be a lot more helpful in terms of understanding wetlands. In addition, a more standardized definition of coastal wetlands and the coastline would be helpful. I shared with you, I guess to that coastline piece, I shared sort of how the water level fluctuates. And so understanding, where do the coasts begin, where do the wetlands begin is a challenge. So sort of having metrics and a way of doing that more standardized across organizations would be really helpful in understanding that wetlands extent. Now I want to jump to that coastal wetlands piece. So different databases also had really different definitions of what a coastal wetland is. So in some cases, databases looked at hydrologically connected wetlands or surface water connected wetlands. Again, things that sort of are difficult to measure in different ways, but sort of could be standardized and improved moving forward. Another way that my research could be improved is to do further research into Great Lakes carbon sequestration and storage. So I alluded to this a little bit earlier. So having for carbon sequestration a way to measure the different factors of the carbon cycle all in sort of one study or sort of some meta-analysis that could really bring together those pieces. In addition, a more robust sampling of carbon storage would really help increase the accuracy of my numbers, right? So more samples and sort of more discussion or perhaps a standardization or sort of best practices around how deep those soil cores can be. So I hope that in the future, sort of these different recommendations I have here can be pursued, and this value of blue carbon in the Great Lakes can be further enhanced and applied to different organizations and really contribute to decision-making and management that accurately reflects the value that Great Lakes coastal wetlands have. So with that, I want to open it up for questions and suggestions and anything else that may come up here at this time. Thank you.